So here is a basic discrete probability problem. So I have the data in another worksheet, but let's look at the scenario. It says based on the consumer transportation survey data, develop a probability mass function and cumulative distribution function, both tabular and as charts for their random variable number of children. So that's what I'll do first, and then I'll tackle A, B, and C, where we're looking for specific probabilities related to that random variable. So the data is going to be found here, and what I'll do is just focus on this data set or this series of data. I'm just going to copy this over into the other worksheet and start working with that. Okay, so if we want to get the probability mass function, what we'll need to do is figure out the different types of outcomes for that variable. And once we get that, we'll get the frequency, and after we get the frequency, we can start getting the probabilities from them. I will go ahead and use the same title as number of children, but I want to look for all of the discrete values in here. So there are different ways that you can do this. One way is by selecting filter and observing the number of distinct values through the dropdown. So we have everything from 0 to 4. So I'll go ahead and say 0, 1, 2, 3, 4. But now I need to do a count on each one of these. So I want to know how many of the respondents have 0 children, how many have 1, etc. So I'm going to say equal sign count if, select the range of data. Here's the range of data. And I'm going to do an absolute reference on this. The criteria is going to be 0, give me a comma, 0, close parentheses. So 13 of the respondents answered that they have 0 children. Next, what I'll do is get the probabilities. And now it can be notated in different ways. It can be P of X, it could be the F of X. Now what I want to do is get the probabilities for each one of these outcomes based off of the frequencies. So equal sign, I'll focus on the outcome of 0, sum of those frequencies, do the absolute reference, hit enter. Format, then I'll bring this down. I'll just do a quick sum to make sure it totals 1. It does, so I know I did everything correctly. So if I were to just disregard the frequency, hide it, here is my discrete probability distribution based off of this data. I'm going to create a visual off of this, so I'll select the random variable as well as the column with its probabilities and go to insert recommended charts, select this clustered bar chart, and we have this visual. Okay, so it also says to, in addition to the probability mass function, which we just ended up getting, we want to get the cumulative distribution function. So the cumulative is going to be the probability for that outcome and anything less than that outcome. So remember, the first outcome, there's nothing less than that. So that's why it's going to be the same as that probability. It's not until that second outcome in your random variable where you will sum up the probability for that outcome and then the probability for any other probability that you have that's less than that outcome. Okay, so here is the cumulative probability. I can go ahead and create a visual off of that by selecting the proper columns and then go to insert recommended charts. And now I have a cumulative probability that looks like this. All right, so now if I wanted to tackle A, B, and C, let's look at A. It says, what is the probability that an individual in this survey has fewer than 3 children? Fewer than 3 children means 2, 1, or 0. So if I focus on either the cumulative probability here, under cumulative for the number of children outcome of 2, that will give me my answer. Or I can just sum up everything from 2, 1, 0, and that will give me my probability, which is that cumulative probability that we have here. For part B, it's saying what is the probability that an individual in this survey has at least one child? So we're interested in everything but 0. So we're interested in 1, 2, 3, and 4. We can easily get the complement by saying 1 minus this probability, and that will give us our answer. Or we could just sum up all of these probabilities that we have here, and that will give us the answer. So different ways of approaching this. Part C is saying, what is the probability that an individual in this survey has 5 or more children? Well, we know that there isn't a 5 in this data, so the answer would be 0. Based off of looking at the distinct values in this data set, there is no one who answered that they have 5 children. Okay, so here is another discrete probability, but particularly we're going to be focusing on a binomial distribution. So you might want to pause and review this problem and we'll get started. So we want to know the number of observations, the number of successes, number, we'll say the probability of success, we'll say the probability of failure, and okay, well, let's go ahead and start off with that for now. So for the number of observations, we're dealing with 200 rooms. And the number of successes is based off of this last part. What is the probability that at least 188 rooms will be occupied? So we're interested in at least 188. So I can say something like this, right? Greater than or equal to 188 rooms will be occupied. Now, the assumption here, we're going to say that the number of successes is going to represent occupied. The probability of success related to occupied would be the complement of the 7% that's given to us, because this 7% is a probability of cancellation. So then in that case, we were saying that we're dealing with a 93% probability of success that they will be occupied. Since the problem here is talking about at least 188 rooms will be occupied. The probability of failure, we can say, is 0.07 or 7%. Now, when it comes down to answering this, we'll know exactly what kind of arguments that we'd want to fill out in our parameters for the binom.dist function. So things can make a little bit more sense. What I will do is create a probability distribution, one that's related to cancellations and one that's related to occupied. So I'll do cancel and occupied. Now I'm going to write the number of outcomes, and we know that there is a total of 100, or so I'm sorry, there's a total of 200. So let me go all the way down to 200. And if I want to get the probability distribution for cancellations, I'm going to say binom.dist, and for the number of successes, it's going to be that outcome of 0. Trials is 200. Probability of success. Now, this is going to be the probability of success for cancellations. Okay, so keep that in mind. So the probability for cancellations is 0.07. Even though I have probability of success as 0.93 here, that's related to the success of it being occupied, which I'm going to do in the second column in a minute. So the probability of success is 7%. The cumulative, I'm going to say false because we're going to look for exactly 0 in our case of the probability for exactly 0. So make sure that you put false for that if you're following along. And I get this probability. I will format this to 4 decimal places, and I'll do the filler option so I get those probabilities for cancellations. Now I'm going to do the same thing, but now I will use the probability of success of 93% that we have here. Okay, so the number of successes would be 0, number of trials is 200, probability of success is 93, and I'm going to say false. So what I'm trying to do is get the probability distributions for both of these two random variables, one for cancellation and one for occupied. Remember, in the problem, we're dealing with occupied. So it's saying, what is the probability that at least 188 rooms will be occupied? If I focus on this column and look for the value 188, which is right here, and everything more than that, that'd be this portion that I have in bold. So if I sum all of that up, you get this probability that we're looking for in the problem, right? Another way to do this, right? So what I did is a very long manual method, but I'm doing this so you understand what we're trying to do here when we're using the binom.dist. So what I could do, and let me just go all the way down where I do have the sum, that where I got the probability. If I say 1 minus binom.dist, and I select 188 for the number of successes, trials is 200, probability is 0.93, and say true. I want to sum up all of these. I'm not looking for individual types of probabilities. So I didn't get the same answer here, and that's because when I was trying to get the complement for a discrete probability distribution like this, the complement of 188 or more is 187 or less. So I need to make sure that in my function that I don't put 188, I have to put 187. This is going to be slightly different when you're dealing with a normal distribution problem. You'll stick with that same number that is presented in the problem, but with a discrete probability distribution like this, you're going to have to use this method by decreasing 1 when you get into complement, because we're dealing with discrete values. We're counting values. We're not measuring them. So here is the same probability answer that we had when we did this manually. Now I could also create a visual on these discrete probability distributions that I created. So if I were to highlight the proper columns, let me just go ahead and focus on the occupied. Recommended charts, press OK. And this is what ends up outputting as my distribution. So we have a bunch of outcomes, and we start increasing our probability as we get more close to the average. The average would be n times p. In our case, we have an n of 200 and a p of 93%. We have 186 rooms that are not canceled. So notice right here we have our visual, whereas we get closer to the average, our probabilities increase. Now we could also get the standard deviation for something like this, and let me just go ahead and do that. So to get the standard deviation, what you have to do is get the square root of the n, which is 200, multiply it times p, and multiply it times the failure, which is the complement of the success. And I'll select that, and this will give me my standard deviation. If you have any questions, let me know. Thank you for watching.